Hello, everyone, and welcome back to class. This is our first screencast for week number 2, and this is more of a review from last week. So, looking at the articles from week number 2. And I think it's nice to talk about these because epidemiology is a foundational uh, discipline of research, you know, whether it's looking at how COVID was spread, looking at death rates associated with COVID, if it's looking at the epidemiology related to hip fractures, if it's looking at the epidemiology related to cardiovascular disease in those who eat a Mediterranean diet versus those who don't, epidemiology is fundamental to understanding risk. But it's always important to put things in context. And I think that's really important when we look at these two articles. The first article, the Guthrie et al. Article, this is a prevalence study, and they compared the prevalence and treatment of hypertension in two different populations. So they chose to look at masters swimmers and then compared it to a large population. The large population came from the 2008 National Health and Nutrition Examination Survey. So they collected a bunch of information and they were interested in comparing things like rates of hypertension and treatments for hypertension compared against the two groups. Now, think about that. A group of masters swimmers, already in your mind, you're probably thinking about what that might look like, and then comparing against a general population. So, with the masters swimmers, I'm trying to find the number here that we had to draw from. So there was 1,346 completed surveys of those people who were representing the masters swimmers group. Okay, very large sample there. And I think if we look coming up, we're going to see a number. I might not have it up here, but it's a pretty large group that you're drawing from when looking at the NHANES survey. So the arrow here is highlighting, it cites here or writes here, since prior investigations of the prevalence of hypertension have not been conducted in master swimmers, our null hypothesis is the prevalence of individuals suffering from hypertension in the swimming population would not differ from that in the general population. Okay, that makes sense as a null hypothesis. So they're probably then, their research or their alternative hypothesis is that there is a difference. This is an example, though, where you probably know the answer without having to read the study. I highlight this here just to highlight that they used SPSS software and they made comparisons using the student's t-test and the Pearson's chi-square test for categorical variables. So the t-test probably for comparing means, and then the chi-square test for categorical variables. If we look here, comparison of mean scores, so using the t-test for those, we see that there's some differences. And it's almost like kind of no duh. And then here we are then comparing percentages, looking at utilization of different drugs between the two groups. One thing I think this study could have done is they could have utilized a prevalence odds ratio. Now, as you looked at the study, yes, it's an example of a prevalence study. Prevalence studies cannot show causation. So somebody might look at a paper like this and go, oh, well, if you are participating in swimming, you're going to be healthier than those individuals who are not doing anything like that. Well, we can't say that for sure because if we go back and look at things, we've got so many different factors here, right? There is, when we look at comparing the percentages of individuals based upon race, well, how does that play a factor? Are certain racial or ethnic groups at risk for higher blood pressure? Is that a factor of their racial ethnic background, or is it a factor of social health care inequities, where they live, availability of food resources, etc., etc.? Then going on to compare things like levels of education. Levels of education obviously different here. And so are those individuals who have a higher level of education, are they doing or adopting other health behaviors that would help with reducing blood pressure? And then, of course, drastically different total time exercising during the past 30 days. So while it's not causation, people are going to probably say, oh, yes, swimming is the difference. But there could be a lot of things going on. And that's what's key for you when you critique an epi paper. Is the author or authors getting too far in front of things? Are they trying to create a causal relationship when you can't do that? Now, again, what's the purpose of a study like this? Because just thinking about it, oh, yes, yeah, obviously, people who exercise, a very specific population, are probably going to be healthier than the general population. This is the type of study from last week I would have talked about being a first study to doing something more rigorous. So maybe the authors were doing this to illustrate that BP is better as a justification to do a different study. For example, maybe to do a study where they're looking at an 8-week swim fitness study to investigate changes in blood pressure in those who are not currently exercising. So I, in the past, tried to look up Guthrie through PubMed and to see if there were any other unique swimming related articles from Guthrie et al. And I found this. Guthrie et al. Master swimmers use more dietary supplements than a large national comparison population in the United States. So what does that tell you? Well, it tells you that, and this is my assumption, I don't know Guthrie at all, but since they're using the master swimmers and that same national comparison group, that they had access to some data sets and then they mined the data to try to come up with some research studies. That's my feeling, my sense about things. There is research out there, though, looking at regular aquatic exercise on blood pressure. So a meta-analysis here of randomized controlled trials. So Guthrie did not go about trying to do that, but there have been people who have looked at this particular question. Now let's talk about the next one. This is an incidence study example. And this one is always kind of a not controversial paper, but one that elicits a lot of discussion, especially from those who have done sports physical therapy or athletic training who've been in this class. And so this is the incidence and causes of sudden death in U.S. college athletes. And whenever a college athlete passes suddenly, especially from a cardiac related cause, it creates a lot of media attention, and people then want to make sure that this never happens again, rightfully so. Just the tragedy that's associated with a young individual dying, you wonder what could we have done to prevent that. So here are the conclusions from the study. The risk of sudden death due to cardiovascular disease is relatively low, with mortality rates similar to suicide and drug abuse, but less than expected in the general population, although highest in African American athletes. A substantial minority of confirmed cardiovascular deaths would not likely have been reliably detected by pre-participation screening with 12 lead electrocardiograms. And that's the big thing is, should everybody be tested with a EKG? What is the time that goes into that? What is the cost? And again, what's the big picture issue? One, from your testing, do you identify people who are at risk of dying? Or do you identify people incorrectly and then exclude them from healthy activities that are beneficial for their heart? So, again, like I mentioned before, there is a desire to reduce the risk of death in college aged athletes. I don't think anybody would disagree that it's a tragic event and that it's something that we should try to figure out. The question is, what's the best way of doing things, and does the technology that we have now correctly identify those people? So what do? They describe their methodology, and then they identify their sources used to identify sudden deaths. And so it appears that they've got a pretty rich, a pretty lengthy number of sources that they comb through to identify all the potential individuals who had sudden death in that population of NCAA athletes. This is a nice table here showing the cause of death, the number of individuals during that 10-year time period, and then factors such as biologic sex, race, the sports they were involved with, and then the level of competition. And so you're able then to see which ones were confirmed, presumed to be cardiovascular deaths versus those that were confirmed cardiovascular deaths. And then, of course, some additional causes of death from there. Now, the breakdown figures are outstanding to include. And what's really nice here is they then looked at the confirmed cases and pulled out then the known diagnoses. And what's really fascinating, like if you look at CAD, coronary artery disease, that's a fascinating one there, because coronary artery disease, people might have that, but you don't think about that being a killer in somebody that's young. And then, of course, some of you might be like, gosh, coronary artery disease, is that a common thing in young people? There was a study, and I only know this because I've taught cardiopulmonary class in physical therapy school, that they looked at military individuals that had died in, I believe it was the Korean War, and they autopsied 300 or so of them and found in 70+% that there was mild levels of coronary artery disease. So yes, young people can have the presence of that for sure. Again, now here's looking at the mortality rates and comparing those mortality rates with the general population. So they're doing a rate ratio, looking to see if the rate of death due to cardiovascular disease is greater than the general population. And that's really something important to think about, because if you're looking at something like this, would you say that collegiate level competition would increase the risk of death, cardiovascular disease death, compared to the general population? No, you wouldn't say that. You would say this is even lower, that these individuals are potentially healthier. And then the bottom one, they're looking at mortality rates and comparing the African American population versus a Caucasian population. And this is a nice figure putting into context then the athletes in the United States dying from cardiovascular related disease, comparing it against all potential causes of death in young people annually. And so it really puts it into perspective. And so they concluded that when looking back at the data, a 12 lead EKG may not have identified people. And is there then potentially a risk of excluding people because you find something on an EKG? And then that goes on to creating more testing of that individual and potentially interventions that may not be necessary. So again, this is a fun paper to look at because again, like I said, it's a traumatic thing. It's not a traumatic thing. It's a tragic thing when a young person dies, and we want to do something about that. Other examples of prevalence, I think I talked about this one before in my volleyball related lecture from last week, that example of what we're looking for with the presentation screencast. And again, when you look in a prevalence type of paper, you should be seeing breakdowns and comparisons. And here's where I used a t-test similar to what we saw in Guthrie et al., comparing different things between those individuals who have patellar tendon abnormality versus those who did not. An incident study example, haven't shared this one yet, but here I looked at jump and hop majors in male collegiate level basketball players who played what we could call small college ball, so Division III, and some NAIA players or athletes. And again, you're going to see these breakdowns here where you're trying to look at what are the rates. And so over here, the total. So when you're looking at a paper, here's the total injury rate. We've got an initial injury rate, so that first injury experienced. And then people came back, and of those 18, there were 11 subsequent injuries. And we can see the breakdown between starters and non-starters because it's interesting to think about, like, are there differences? There was not. How about looking at guards and forwards? Being a taller person myself, I'm 6'5". I have a little bit of more of a interest in the big man, so to speak, and the pounding that goes on when you're posting up and so forth. Maybe those individuals are getting hurt more. Well, these were non-contact related injuries again, so there was again no difference experienced between guards and forwards. All right, so you are going to continue or proceed with discussion topic 1. Sorry about that. Let me rephrase. This was discussion 1 from last week, and so I've gone through and provided some comments, whether they were this looks great or what about this type of thing this week, and we'll talk about this more in the main lecture. You're going to be doing a response to your classmates. And then just to highlight, there are some interesting topics that students come up with, and these are some past examples. And I do have to say that coming up at the end of the month, an individual from a cohort, I can't remember how many cohorts ahead of you, he's going to be doing his defense, his final defense, and his dissertation is really interesting, where he's applying epidemiologic methods to understanding risk for denial of payment. And so it's really kind of a unique way to apply epi-stats and epidemiologic methods to identify, are you at greater risk of not getting paid based upon when you bill, or the type of insurance you're billing, or the type of discipline you're involved in. So, if you have any type of interest in epidemiology and, you might be like, oh, maybe I want to do this. Check that out. That's coming up near the end of the month. I think Rocky Mountain University announces those defenses to everybody. But if you're curious, you can always email me, and I'd be happy to share the date and time that is occurring.